Hello everyone, today we will be presenting our project, a machine learning and deep learning intrusion detection workbench system. To start things off, we want to touch on the fact that in a modern world, securing systems is a complicated task that faces different obstacles. Most notably, that malicious attacks are constantly changing, security systems must detect both known and zero-day attacks, attacks must be detected in a timely manner to avoid disastrous outcomes, and finally, the complexity of development and operation of such security systems. To highlight the importance of security systems, it's worthwhile to mention the effects of attacks on organizations and businesses worldwide. To elaborate, according to Dell's Global Data Protection Index, 35% of organizations suffered from cyber attacks in 2019, compared to 28% in 2018, which highlights the fact that cyber attacks are definitely on the rise. To add, Red Hat states that the cybercrime business is estimated to be a $100 billion business worldwide, which highlights the staggering amount of resources allocated within such business.
With that being said, we asked ourselves, how can we prevent the occurrence of such attacks? This is where the role of intrusion detection systems plays a part. Intrusion detection systems are able to detect such attacks by monitoring and analyzing the packet flow or logs of the network activity, and then report the detection of any potential attacks on the organizational network. Intrusion detection systems can be categorized into two main different types: signature-based detection and anomaly-based detection. Signature-based intrusion detection systems work by monitoring the network and identifying whether a packet has a signature, such as a specific byte sequence, of a known attack that has been previously fed into the system. On the other hand, anomaly-based intrusion detection systems work by utilizing machine learning and deep learning approaches to determine what is considered normal packet activity and what is considered a malicious one. Anomaly-based intrusion detection systems have the great benefit of detecting zero-day and novel attacks. However, despite their immense promising potential, they are fairly a recent technology and are currently undergoing intensive research and development.
Therefore, to help facilitate the research and development of anomaly-based intrusion detection systems, we present our solution. A workbench that supports the tasks and pipelines built in the research and development of such systems, and allows the users to carry out such tasks with minimal effort and repetitiveness through an intuitive and simple design that abstracts the complexity and code knowledge behind such tasks. And to verify the need for such systems, a survey has been conducted to gather opinions of many different users from diverse backgrounds, varying from general audience to security professionals. The result of the survey unveiled an overwhelming interest and a critical need of our proposed system from multiple different professional and academic backgrounds. Diving into the functionality of the proposed system, 5 main features are highlighted as the following. First, the ability to perform live packet attack detection. Utilizing third-party network intrusion datasets. Perform various pre-processing and classification tasks, providing precise analysis details regarding the detection time and performance accuracy. And finally, generating comparative metrics and analytical reports. The innovation behind this project comes in many aspects. Firstly, it integrates various activities that are needed by security professionals, including previously mentioned live network traffic attack detection, and importing different third-party and user-defined datasets. Secondly, this system fulfills untackled market needs. It also utilizes the implementation of state-of-the-art development platforms. And lastly, present solution greatly cuts down repetitiveness and time needed for developing anomaly-based IDS pipelines.
And to illustrate our current progress, a paper has been published in the IEEE regarding a comparative study that discusses the utilization of many different machine learning and deep learning approaches in the detection of network attacks, the challenges tackled in the process, and the highly promising results of such approaches. Secondly, a proof of concept version of the proposed system has been developed, ironing out a lot of potential challenges and risks while also verifying the feasibility of the system during the process. And now let's take a quick look at a demo of the system. Using an intuitive and simple yet effective interface, the preliminary system allows the user to import different third-party network datasets, view general statistics and visualizations about the chosen dataset, giving the user a good idea about the dataset's size, features, structure, and composition. Choosing various classification methods, each of which has its own dynamically generated parameters which can be tweaked according to the user needs. And finally, allowing the user to perform the classification task using the utilized classifier and view metrics regarding the accuracy of detection of different attack types and the overall accuracy of the used classification method.
Future work possibilities were studied to acknowledge how we can cover areas that can help enhance our system. Firstly, extending the workbench's capabilities in all aspects. Secondly, integrating the workbench with CVE listings to add newly detected attacks. Thirdly, expanding the system to support different networks, such as Internet of Things based ones. Along with that, enhancing the available IDS network datasets and solving some of their inherent issues, thereby providing more realistic and usable datasets. And last but not least, developing mobile-specific anomaly-based intrusion detection systems. At last, we thank you for your time and we hope that you enjoyed watching our video.